things to kind of clean up. We're just going to continue doing what we've been doing yesterday. There was some confusion, which means there's a great opportunity to have discussion. We're identifying patterns and making rules for linear equations. So I have to say, you guys are great at identifying patterns. The biggest mistakes I'm actually seeing is how to present the linear functions, which is a really easy thing to fix. We just have to think about how we're putting our information together. And so that's what we're going to go over today. I'm going to quickly review the vocab first. So a function equation is an equation where every input has only one output. A linear equation is an equation that creates a line due to the constant rate of change, and the m stays the same. So we've been doing this for a couple of days now. We have steps to determine the rules of a linear function. I'm just going to quickly go through what that means. So we examine the input and the output by asking, how did the output turn into the input? Excuse me, I said that backwards. How did the input turn into the output? I apologize. And you can try all operations, addition, subtraction, multiplication, division. I'm focusing on addition, subtraction, multiplication because division's actually been really hard for us to write in the computer, so I'm not going to really stress it at this time. Once you have an idea, you're going to test each pairing. And it's actually this step that I changed up how I'm asking you guys to present your thinking, because I think it'll actually help you determine your rule. So if it works for each pairing, write the rule in terms of f and f of x, and that's just the y. And this is an example. I've been seeing a lot of people do a really good job in this, but sometimes the constants are just kind of not in the right place. So that's what we're going to work on today, and that's why I changed up how you're doing the worksheet a little bit. Let's get into it. So the first one, you can see that I already set it up for us. We have 2 that goes to a 4, a 3 that goes to a 5, a 4 that goes to a 6. I'm actually going to delete it so you can actually see my thinking. And a 5 that goes to a 7. Now, what I'm going to ask you to do is actually show what you're thinking right now. So if the x is 2, so we have an x, which is 2, what did I have to add to that x to make it 4? Well, x plus 2, we can actually, if we want, I think this might be used. X plus 2 equals. So 2 plus 2 equals 4. All right, let's look at our next x. We have 3. 3 plus 2 equals 5. So this looks like I could have figured it out. I would ask you guys to go forward and make sure it works for 4 and 5. If it does, it's going to look like f of x equals x plus 2. So f of x is the output. We always put that in the front. The x is the input. And what did we do? We did plus 2. So that's where that came from. Oops. Formatting. So I'm going to continue this one. I really want to make sure you guys are successful, so I'm going to help you with this one. So plus 2 equals 6, which works. And it has to be the same equation for all of them, right? So if this was like an 8 or something like that and it was plus 3, this wouldn't work. So we have 5 plus 2 equals 7. And so that's why it works. So we have f of x equals x plus 2. And that's where the x plus 2 comes from. Now looking at the next one, we have 2 to negative 1, 3 to 0, 4 to 1, 5 to 2. Now this is why we test each one. So we have 3 to 0. Now we can get to 0 from 3 in 2 different ways. We get times by 0, which equals 0, right? Everything times 0. We can also subtract 3 to make it equal 0. But only one of these will work for each one. So now let's figure it out. So if I times 2 by 0, that would equal 0, and it equals negative 1. So that one cannot work. What if I took 2 and I minus 3? Well, that works because that would equal a negative 1. Is it easier if I go like that? Maybe it's easier if I go like that. So because this is a minus 3 and this is a minus 3, it is not minus 0. And you're going to go through, prove it, and write that final equation using f of x equals. The next one, we have zeros again. Then we have 1 and 5 and 1 and negative 1. So let me think. There's a couple things we can do. Well, we have a 0 to 0, which is challenging. But we have a 1 to 5. So let's look at the 1 to 5. So again, like the last one, there's 2 different options I can think of immediately. 1 plus 4, definitely 5. But also 1 times 5 equals 5. So we have to figure out which one works for all of them. So I'm going to start with the 2 to 10. So 2 plus 10 equals 6. I mean, 2 plus 4 equals 6, not 10. So that cannot be it. Now we have to test the times 5. So we have 2 times 5, and that would equal 10. So that one worked. Let's try the other ones now. And that's what you're going to do. And then you're going to set it up, f of x equals. This one I'm actually going to do with you because this is actually my longer question. So we have times 5. I'm sorry, guys, I'm all over the place today. 0 times 5 equals 0. And then negative 1 times 5 equals negative 5. So this one works. The reason I'm going over this is because the times 5 would be 5x. So when we're multiplying, that's when it goes in front of the x. And looking at number 1, when we add, that goes to the n, plus 2. So number 4 is a challenge. I'm going to write that. It is a challenge question. You guys got it. We have 5 to negative 5, 6 to negative 6, 7 to negative 7, 8 to negative 8. I'm going to tell you that the first 3 was an addition, a subtraction, and a multiplication. This one could be any of them. I believe you got it. Feel free to email me or comment for questions. And I look forward to grading your work. Nice job, guys.